Our topic for our second class will be factoring trinomials. Now let's move into factoring trinomials. So we're going to look at two types, simple and more complex trinomials. So my notes on trinomials. When I say trinomial, I mean a second degree equation. So my biggest power would be a square on a variable. They're also the standard form of quadratic equations, which is where, like it or not, if you got to this point, you have seen it before. You just probably blacked it out, as many people do. So when we write the standard form, and this is important because we'll use this again, we always make them with this ax squared plus bx plus c, okay? And a and b, as well as c, can be any number. They can be -5, they can be +21, it doesn't matter. But a, b, and c represent numbers that go with variables. So if you look at our examples, we have x squared plus 6x minus 23. So in that case, a always goes with x squared, and I can't see a number, so a is 1, which is important. And b, is 6, and c equals -23. If your trinomial is not in descending order, that doesn't change anything. A still goes with the x squared. So in this case, a is -7. B goes with x always. B is 3. And C is -2. So we're going to start with factoring simple trinomials, and that just means a is 1. So your leading term will be x squared without anything in front of it. Okay, so looking at our examples, is number 1 simple or complex? Simple, right? Because a is an invisible 1 in front. So simple for number 1. What about down here? Simple or complex? There's a 1, but it's not the a value. A equals 3. So this is a more complex one. Looking at number 3, simple or complex? Now be careful, because remember, common factoring. This is where you really want to be using your common factoring. It looks like a complex trinomial, but I can divide 2 out of all the terms. And it has some y squareds as well. That's fine. We're looking at these x terms. And in this one, once we factor out that 2, we see that we have an a that is equal to 1. So this is actually simple. Be careful. And for our last one, the term in front is not the a term, it's a b term. A is actually -4. So this is complex. There are a lot of strategies for factoring trinomials. I'm a big fan of the product and the sum strategy. So this is how I set it up. There's a lot of information in these next few slides, but I'm going to take you through. So if you're given a trinomial and you have ax squared plus bx plus c, and we're going to say a is 1, we're going to look for factors of ac. And when I say ac, or the ac line, that means a times c. Now, in simple trinomials, a is always equal to 1. So the AC line really is just whatever c value you see there. And the b line just takes the b from there. So if I look at one with real numbers, your AC line is always a product. It's always a multiplication. And you're going to take a times c, so 1 times 10 goes there. And for your b line is always an addition line, and it always looks for that b value. So what I'm really telling you is that I need to find 2 numbers that multiply to 10 and add to 7. So you're always going to be taking that AC line, and you're going to be looking for factors of 10. How can you make 10? You can make 10 by doing 10 times 1 or 5 times 2. So if this is going to be factorable, some of those have to work. 10 times 1 makes 10, but 10 plus 1 adds to 11. No good. 5 times 2 multiplies to 10, and 5 plus 2 makes 7. So that is good. And when we put that into factored form, we're just going to write x plus 5, because that's a 1 factor we found, and x plus 2. There's our second factor. And if we go back and expand these using FOILs, guess what we're going to end up? Right back at x squared plus 7x plus 10. So now I want to break down what you can expect to be doing with different values of b and c. So you can have 4 combinations. You can have positive b value, positive c. So the first thing I always look at is the c value. And let's just use our same example there, x squared plus 7x plus 10. If your c value is positive, it means that you had to multiply 2 positive numbers or 2 negative numbers. So when I look to the b value, so I check for c, so I know I'm going to have numbers or factors with the same sign. And if I look to the b value, if it's also positive, I know I've created this situation. Two factors that multiply to 10, 5 times 2, and add to 7, 5 plus 2. Now, I can still have a positive c value, but end up with a negative b value. All that means is I'm still going to use 5 times 2 equals 10, but in order to make 5 and 2 equal negative 7, they must both be negative. Negative 5 times negative 2 is still positive 10. Negative 5 plus negative 2 is negative 7. So in this case, I look at my AC and my B line, and I discover that to make this combination, I need x minus 5, x minus 2. If C is negative, we know that our 2 factors will have different signs. So let's look at x squared plus 3x minus 10. And we're going to do the AC line thing again. We need to make negative 10. A times C has to equal negative 10. And A plus, sorry, sometimes my multiplication signs look like plus signs, has to equal positive 3. So we know to make negative 10, we're going to have one positive, one negative. And the key with this kind of thing is look to your B. If B is 3, you're looking for factors of 10 still, and I'm dropping the idea of negative 10, that are 3 apart. Okay, so my choices still remain 10 and 1 or 5 and 2. 10 and 1 are 9 apart, so it's not going to work. But 5 and 2 are 3 apart, and that's my B value, so that will work. So I'm going to write down the 5 and the 2. And I'm going to look to my B value. Now, my B value is positive. So that means the bigger number, the bigger absolute value of a number must be positive. So I'm going to make the 2 negative. And I'm just going to check it with my little product sum lines. Is 5 times negative 2 negative 10? Yes. Is 5 plus negative 2 positive 3? Yes. So when I do this, my factored form, x plus 5, x minus 2. And let's take it down here for the last combination, negative b and negative c. I still need to make negative 10, and I need to make negative 3. So same idea. If c is negative, that means you're looking for factors of 10 that are b apart or 3 apart. Okay, it's going to be 5 and 2. But this time my b value is negative, so my bigger number has to be negative. My bigger absolute value has to be negative. So I do this, and the factored form of this number will be x minus 5, x plus 2. So 4 kind of combinations. And here's it all summed up in a chart. Make this a little bigger. So if C is positive and B is positive, you're going to have two positive factors. C is positive, B is negative, you're going to have two negative factors. And depending on whether B is negative or positive when C is negative, it tells you which number will be negative, which number will be positive. But you can always test it with the math. So let's do some and do it the long way. So that AC line and that B line. AC is always your product line. I need things that are going to multiply to 1 times 6, which is equal to 6. And I need things that are going to add to 5. So always looking at factors of 6, my choices are 6 and 1 or 3 and 2. 6 and 1 add to 7, no good. 3 and 2 add to 5. There you go. B was positive, so I know that they're all going to be positive, and the answer for this one will be x plus 3, x plus 2. So notice I'm taking whatever I put into these blanks, and that goes into my factored form. All right, let's look at number 2. I need to multiply to 8, positive 8, yet add to negative 6. So I see that C is positive and B is negative. So I'm looking for two negative factors. Factors of 8, I'm just going to think about what those are. I can have 8 and 1, or I can have 4 and 2. 8 and 1 are going to add to 9, no good. 4 and 2 add to 6. So 4 times 2 is 8. 4 plus 2 is 6, but I need to make negative 6 and positive 8. Everything's negative. And my factored form of x squared minus 6x plus 8 turns into x minus 4, x minus 2. Check your answer. Use FOIL. Try and get back to your original trinomial. If you can't get back or the signs are different, you did something wrong. All right, number 3. I need to multiply to negative 9. And because C is negative, the two things that are going to multiply to negative 9 must be 8 apart. How do I make 9? 3 times 3. Oh, that's 0 apart. That's no good. And 9 times 1, which happens to be 8 apart. So those are the correct factors. So I'm going to do 9 and 1. 9 and 1. 8 is positive, so 1 must be the negative one. 9 plus negative 1 equals positive 8. And my final answer, last example, I need to multiply to negative 20, so I'm looking for one positive and one negative number. And I need to combine or add negative 1, which means the two factors must be 1 apart. How to make 20? More choices. 20 times 1, 10 times 2, 5 times 4, and I think that's it. So these are 19 apart, so that's no good. These are 8 apart, so that's no good. 5 and 4 happen to be 1 digit apart, so they're going to work for me. Who's going to be positive? Who's going to be negative? Look to this. I need to make a negative answer, so the bigger absolute value will be negative. Just making sure both those AC and B lines are true. Yep, I did it right. All right, so just kind of piling on a bit. Now remember what I said. You can factor number 1 with the negative in front. Pull it out. I would pull it out. It's way easier because then you have just kind of your positive A and you don't have to think about anything. And factor the stuff inside the brackets. So I need to multiply to negative 15, the AC line, and I need to be 2 apart because C was negative. 15, your choices are 15 and 1 or 5 and 3. 5 and 3 happen to be 2 apart. There you go. One of them has to be negative to make this work, and it's got to be the 3. So when you write your answer for this one, anything you took out, Here it was just -1. Remember to write it in front of the two binomials. That's my classic mistake. I always forget about them stuff. Sorry. Put that back. X plus 5, x minus 3. And if you were to expand the binomials and then reincorporate, distribute the -1, you'd end up right back here. Okay, so let's look at number 2. I've only told you how to factor simple trinomials, so I bet you can divide out the 3 that's the a value. And you totally can. All of these terms are divisible by 3, so pull it out. 27 divided by 3 is 9, and 60 divided by 3 is 20. So looking around before I start, I'm going to have something times something equal positive 20. And those same two factors must add to -9. I know they're both going to be negative because they made a positive number. So 20 factors, once again, 20 and 1, add to 21, 10 and 2, add to 12, 4 and 5, add to 9. Those are my factors. And because 9 was negative, I need them both to be negative. So my final answer for this one, don't forget to write that 3 in front. Number 3, we've got a 2 in front and a negative. Pull them both out. -4 divided by -2. -2 divided by -2. All right, so now we're going to factor. I need to multiply to 1 and add to 2. Well, there's not many choices here. The only way to make 1 is by multiplying 1 times 1. And it happens to be that when you add them, they make 2. So my final answer here, leave that -2 in front, and then x plus 1 squared. Or you could write it as -2 x plus 1 times x plus 1. Same. Last one, we're ending with an easy one. We need to multiply to 11 and add to 12. Well, 11 is prime, so the only way to make it is 11 times 1. And that's one we often forget about. Don't forget about that number times 1 as being possible factors. 11 times 1 is 11, but 11 plus 1 is 12. And our factored form, x plus 11, x plus 1. There are lots of ways to do factoring. So if this isn't gelling for you, or if you have a system that worked before, go ahead and use them. I'll absolutely put up some resources in the shell that you can look at. Now that we've mastered factoring simple trinomials where a is equal to 1, let's move on to harder trinomials. So what makes a trinomial harder? Like I just said, the a value will not be equal to 1, and you cannot common factor it to make it 1. So my question here is, which one is a complex trinomial? And when I say complex, I mean hard, I mean difficult, I mean a not equal to 1. So obviously this one is simple. Looking at this one, I have 3, -19, and -14. So this is a hard or complex trinomial. And looking at my third one, I have -3, -9, and +12. I also have too many x's, but there's common factors here. So always getting that leading term without a negative. So I'm going to factor out -3. I can factor out an x, and I'm left with x squared plus 3x minus 4. So the same as the first one, just in disguise. So this one is actually simple as well. Just have to look a little more carefully. So I keep saying harder and complex, like this is going to be a really big challenge. They're not that much harder. There's just a little more work. And I'm going to use a cheat or a trick that is kind of based in decomposition, which is one of the methods, but it's very time consuming. So I find that this trick is nice and fast. So that's what I'm going to show you. But if you have another way of doing it, by all means, go for it. So We're going to look at 2x squared plus 7x plus 6. First step, always, 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 common factor. If you don't common factor, this thing doesn't work. So I look up here, 2, 7, and 6. Nothing goes into all three of those, so this cannot be common factored, so I can proceed now. So we're going to do the same thing we did before. My AC line and my B line. AC is a product, B is a sum. And now be careful, when I say AC, it means A times C. So when A was 1, we just looked at the last number, but now we have to pay attention to the leading coefficient as well. So the AC line is something that multiplies to 12. And the B line is going to be the same two numbers adding to 7. So you can think about it, you've got 12 and 1, you've got 6 and 2, no good, no good, and you've got 3 and 4. And those work for you. Everything's positive, so both factors will be positive. Okay, so I've found my factors. So number 2, write them as denominators of two fractions with a numerator of ax. So I'm looking here. A is 2. So I'm going to write 2x over 3, which is one of my factors. And I'm going to write 2x, ax, over 4. I'm going to make these into binomials in a second. So I've done this step. Now, reduce the fractions if you can. So we're just going to act like 2/3. Can 2/3 be reduced? No. So I'm going to leave that one. And I'm going to look at my second fraction. It's like 2/4. Can 2/4 be reduced? Yeah, that can be changed into 1/2, right? Or 1x over 2. So these are your binomials, and the way it goes is you write down the first numerator, 2x, and the denominator plus 3. I wrote down plus because it was a positive 3 denominator. And I look to my second fraction, and I'm going to look at this one because I reduced it, x plus 2. Now, last step, check your answer. So use FOIL to go back. 2x times x is 2x squared. Outside is 4x, inside is 3x, plus 7x. And last is 2 times 3, which is 6. So we know that's correct. Now we're just going to do lots and lots of examples. Number 1. And I'm going to write common factor because it has to be your first step. Oops, come here. There we go. I can't for number 1, so that's fine. My AC and my B. So I need to multiply to 2 times 5, which is 10. And I need to add to 11. So two numbers that multiply to 10 and add to 11, 10 and 1. Satisfy both things. Okay, so the second step, the weird trick, and you only do this trick if a is not equal to 1. If this had just been a simple one, you would stop and the answer would be x plus 10, x plus 1. But it's not. So we write down ax twice as numerators, and we write down our two factors that we solved for, 10 and 1. Now, we're going to go through, and if we can reduce the fraction, we will. 2 over 1 doesn't reduce, but 2 over 10 could be 1 over 5. And then we're going to write that down as our answer. So our first binomial is the numerator plus the denominator, and our second binomial, numerator plus denominator. And that's your answer. And make sure you check it. Okay, number 2, our AC line and our B line. So we're looking to multiply to 15, 5 times 3, but also combine to negative 8. So I know that both of my factors will be negative, just because B is negative and AC is positive. So I'm going to sneak these in. How do I factors of 15 that make 8? Not 15 and 1, has to be 5 and 3. Okay, so far so good. write down ax twice. So taking that a value and just putting an x beside it, and then writing down your two factors, -5 and -3. I can oh, this could be 1. This could be 1. Noticing that negative sign is going to stay there, and I can't reduce 5 over -3. So my first binomial is going to be x minus 1, and my second binomial will be 5x minus 3. Continuing. Oops, that should be a plus sign. Sorry, it's too messy. Back it up, buttercup. There we go. So we're looking to do 7 times 5 is 35. And we need to get to -12. Factors of 35, and they're both going to be negative from the looks of it. Factors of 35 are 35 and 1, which doesn't work, and 7 and 5. So interesting in that we kind of started with 7 and 5, and we came out with 7 and 5, and that happens sometimes, but they are separate. So okay, we're going to do 7 times 5, 7 plus 5, but because the product is positive and the sum is negative, they must both be negative. And same thing. AX at the top of two fractions, the factors I just found as the denominators. Let's go ocean. Simplify if you can. Oops, sorry. Try that again. Simplify if you can. That's a 1. That can be a 1. 7x minus 5 won't change. So once again, I have x minus 1. This time to 7x minus 5. Continuing. Checking for common factoring. It's the most common thing I see. People don't do the common factoring, so I always try to harp on it. All right. Okay, so just going a little more quickly. Okay, so I need to make -12. So remember that when c is negative, I kind of think of it more as how far apart are the two factors instead of what do they add to. So I need factors of 12 that are 4 apart. You can think of it any way you want. That's how it works for me. So I know it's 12 and 1. Those are 11 apart. And then I go 6 and 2. Those are 4 apart, so I can stop. And I just need to know, how do I make a positive 4 with a 6 and a 2 if the 2 is negative? And we're going to do the same thing. Write down AX over your two factors. Okay, 4 over 6 can be 2 over 3. And 4 over -2 can be 2 over -1. So this time both of our binomials changed. 2x plus 3, 2x minus 1. And remembering, you can always just check your answer if you're not sure. Number 5, big numbers. I hate big numbers, so I always kind of look for a common factor right away. Big numbers that are all divisible by 5. So let's start by doing this. Common factoring out of 5. And see what we're left with. 5x squared plus 9x minus 2. And this binomial is what we're going to work with. I'm sorry, trinomial is what we're going to work with. We're just going to ignore the 5 outside. So we're going to do all the stuff with the things in brackets. So I need to multiply to -10, 5 times -2, and I need to add to +9. Okay, so once again, because C is negative, or AC is negative, I know that I'm thinking about things that are apart as opposed to adding to, a difference instead of a sum. And 10 and 1 are 9 apart. And it's going to be positive 9, which means I need one of my factors to be negative, and it has to be the 1. So continuing on, using this a value, ax twice, my two factors that I just found, and reducing if you can. Nothing can be done with the second one. Now, don't forget, when you started this, you did a common factor, so it has to be in your answer as well. And we're going to have x plus 2, 5x minus 1. Okay, last one. Kind of gross numbers again, all divisible by 3. Leaving behind 2x squared minus 11x minus 6. And they just come faster and faster as you do these. And if it's something that you're really stumped by, just start listing the factor pairs to see what makes what. Okay, I need to multiply to negative 12, and I need to add to negative 11. My AC line is negative, so I'm looking for factors of 12 that are 11 apart. And that's only 12 and 1. And I need it to be negative, so the bigger absolute value will be negative. Going on to the trick part. Reducing if you can. Can't reduce the second one, remembering to bring down whatever you common factored out for your answer. Okay, so our last slide, our most difficult examples. We'll start with number 7. Same. I need to multiply to 12 times negative 5, negative 60, big number. Lots of factors, and I need to be combining to 4, but because AC is negative, that means 2 factors of 60 that are 4 apart. So, you start your thing. They have to be relatively close, so I know that to get to 60, I can do that 12 times 5, but that's no 4 apart. I can do 15 times 4. That's way too far apart. And, try what you want, and then eventually you might get to, 10 times 6. Those two numbers are 4 apart. I want the 4 to be positive, so that means the 6 is negative. Just looking it over, checking that it works. Yeah. Okay, let's cancel if we can. This time we can reduce on both. 2 goes into 12 6 times, and it goes into 10 5 times. And I see I've dropped the negative here, so I'm going to put it back. And then 6 goes into 12 2 times, and into 6 1 time. So there are my binomials, 6x plus 5, 2x minus 1. And remembering, if you're not sure, just check your answer. Looking at number 8, I need to make negative 72. And I need to combine to negative 14. And looking at the negative on the AC line, I know that I'm looking for factors of 72 that are 14 apart. Okay, so you can take some time to do this. It's going to be 18 and 4, which is not one that comes to mind right away with 72. So there's no shame in a bit of calculator mashing, like just being like, how can I make 72, and just dividing and looking for those even numbers. Okay, and this time I need my 18 to be negative. Write down ax twice. Negative 18 was one factor, 4 was the other. Switch my colors. 2 can go into 8, and it can go into 18, so it's going to go 4 over 9, and that's the end of that. 4 can go into 4 one time, and 8 2 times. So noticing also, this is fairly obvious by now, but you don't have to reduce them the same way. Just get each fraction down at any way you can. Sorry, I was thinking there for a minute. 4x minus 9, 2x plus 1. All right, so looking at number 9, our last example, when I look at this, I would hope that you'd be like, oh, hey, difference of squares, and you would solve it that way. But if you don't, I just want to show you that using this type of factoring also works. So just recognizing that 4 is A and 9 is C, because the B value is always tied to the x to the power of 1, and we don't have that here. So when we build this, we want to multiply to negative 36, which is 4 times negative 9, and we want to add to 0, because basically there's a 0x here that we can't see. All right, so we know they're going to be the same numbers. We know they're going to be opposite. The only way to do that with 36 is to do 6 times negative 6. And we write down our two fractions. Four can reduce to 2, 6 can reduce to 3 by dividing both by 2. Same here, reducing that fraction 4 over 6 to 2 over 3, but a negative 1. So 2x plus 3, 2x minus 3. So another way to solve one when you're missing that b term. And that's it for our harder trinomial section.